Alright, so this is going to be a quick video over finding the formula for an ionic compound using valence electrons. We're just really looking at the ionic bonds. We'll go into more detail about an easier way to find the formula, but for now I just want you all to see how the charges balance out. So starting out, you need to be able to draw a Lewis dot structure for atoms. And so if we look at sodium has one valence electron, it's in group 1, so it'll look like that. And just for good measure, sodium would have a +1 charge. Also anything in group 1 would have a +1 charge because they all have one valence electron. Magnesium has 2 valence electrons, and so when you draw the Lewis dot structure for atoms, you draw them one at a time. And then you can go back and pair up if you use all 4 spaces. So if you have one here, 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 and here, then you can go back and pair up. But that's not necessary here. And so anything in group 2, like magnesium, would be +2, right? And if we look at sulfur, it has 6 valence electrons, so we would go 1, 2, 3, 4, 5, 6. It wants 8, so it will gain 2. So anything else in group 6, like oxygen, it would have a -2 charge for the ion. Alright, so let's move on to the compounds. So the first one I'm going to do is between sodium and chloride. So I'm going to draw the Lewis dot structure for sodium first. It has 1 valence electron. And then I'm going to draw the Lewis dot structure for chlorine. And it's got 7. So 1, 2, 3, 4, 5, 6, 7. And it doesn't matter what side you draw the pairs on. All I know is that chlorine has to have 3 pairs and 1 completely by itself. And so since chlorine is the nonmetal and it's way more electronegative, it's going to take this electron and it's going to turn this into sodium plus, and then we're going to have chlorine will turn into chloride, and it'll be negatively charged. And so the formula for this, because there's only 1 sodium and there's only 1 chlorine, is going to be NaCl. And I don't care if you write it like this or if you write it like this. Either way works for me as long as you get the right answer. Alright, so in this next one we've got magnesium, and it has 2 valence electrons. And then we have bromine, and it has 7. And so bromine can only accept 1 more electron right here. So after it accepts that 1 electron, it can't accept anymore. So magnesium isn't going to just give up 1, it wants to give up both of its electrons. So you're going to have another bromine down here. And then this electron can come down there, right? So this took 2 bromines instead of just 1. So if we redraw this, magnesium now has a 2+ charge, and we've got 2 bromines. And so the formula for this would end up being magnesium, bromine, and then we have 2. So it's MgBr2. Alright, next we have magnesium and sulfur. So I'm going to draw the electron dot structure here for magnesium. Magnesium has 2 valence electrons, and then sulfur has 6. So sulfur is the more electronegative one, so it takes the electrons, and it can take 2, and magnesium has 2 to give, so it will give both of them. And so what we end up getting is magnesium with a 2+ charge, and then we have sulfur with a 2- charge. And so that's only 1 magnesium and 1 sulfur. So it's going to be Mg S. Alright, and then the last one that I have here, we're going to have magnesium with 2 valence electrons, and we're going to have phosphorus, which has 5. So I've got 1, 2, 3, 4, 5. And so this electron can come up here, while this electron can go down here. Well, phosphorus still has an open spot right here, so we need another magnesium. And so then this electron can go here, but now I have 1 electron left on magnesium right there. So I'm going to add another phosphorus. And so this electron will go up there. And now I have 2 more electron spots here and here for phosphorus. So I'm going to add 1 more magnesium. And so this will go, whoops, this will go here, and that will go there. And so now all my electrons have been moved to the more electronegative atom, and magnesium has lost its electrons. And so what I end up getting is 3 magnesium 2 pluses and 2 phosphides with a 3 negative charge. And then my formula is going to be Mg3P2. And that's all there really is to it. You just have to make sure that all the electrons are moved to complete an octet on one atom, and they're all lost on the other atom. And they're going to be always lost on the metal, and they're always going to be gained on the nonmetal.